Okay guys, we understood the situation when vehicle was moving along horizontal circular road. Here I forgot to mention one thing. M was mass of the vehicle. Alright, okay fine. Whenever we were trying to compare parameters of Vmax with µs and g, R was kept constant. The radius was constant. µs, different µs's, the same radius we are talking about, and different gravitation as we talked about moon with same radius when the vehicle is moving with same radius on moon, and vehicle when it's moving with same radius on earth. And even in case of static friction, when we are talking about oily, smooth and rough road, all those three parameters were compared with same radius. Alright, so that was one thing which I should have mentioned there in my earlier video. So here I do mention that. Alright, okay. Now coming to well of death. Now when we talk in terms of well of death, now it's a well, huge well. You might have seen in circus and all such exhibitions where you see motorbike, two-wheelers, or at times also you see vehicles moving around, jeeps and all moving around the well like that. Alright, so assume this to be a vehicle moving. Alright, now when vehicle is moving around in this well like this, alright, what are the forces acting on it? Obviously these are the wheels, and mg is trying to take it down, alright, and frictional force is trying to act in upward direction. So mg is acting in downward direction and fs is acting in upward direction. That's one thing. Then since it's a circular motion, so obviously centrifugal force would be acting outwards. So this is FCF. Alright, this is Fs, static friction, mg downwards, FCF outwards, that's centrifugal force. And we always say that normal is always perpendicular to the surface of where the vehicle is moving. So this is the surface to normal to that. So n is normal to that. So this is n and FCF. So these are there in opposite direction, and these are the forces which are there in opposite direction. Another thing, static friction, when we talk about, it is also equal to μsn. That is what we have already derived over here. Alright, fine. So let's get into derivation. Now normal is balancing centrifugal force, which is this or this. We saw rotational, linear, done. Now here, now mind you, here, now there we were trying to balance this divided by that, and then we got this all. Here it is very much essential for us for understanding that the static friction has to be less or equal to μsn, or it has to be equal to or less than μsn. Alright, because if static friction is greater than this, the vehicle won't move, it would stick to that place only. Fine. So static friction has to be less than or equal to μsn. Fine. Okay. Now when we are talking about Fs is balancing what? mg. So we can substitute mg there. Alright. And normal is balancing centrifugal force. So we can substitute there centrifugal force. It could be linear, it could be angular. So we have substituted linear rotational motion, centrifugal force. Alright, so mg is equal to this. We know that this m cancels. I again repeat, m is mass of this vehicle, whatever it is, two-wheeler, four-wheeler, it's mass of that vehicle. Alright, so mm gets cancelled. So what we end up with is g less or equal to μs v square over r. Fine. Okay, so what we are interested in, v. So we take r there, it becomes rg, μs we take it down here, so it becomes this, and then we root both the sides. So v square becomes v, and here we get root of rg over μs. So this is our final formula that we have got to keep in mind when the vehicle is moving in well of death. Alright, so this is the formula which we would be using for our numerical purpose. I hope it's clear. Alright, so compare this with this. Here it was and here it was. Alright, so preventing this toppling out, and here preventing dropping out. Alright, so these are the formulae which you have got to keep in mind for our numerical purpose. Okay, I hope it's clear. right?